Alright, so today we're looking at calculating probabilities using continuous probability density functions. So our intentions are gaining the knowledge in using probability density functions to calculate the probability of a range of continuous random variables. We'll be successful if we can record that the area under the curve for these things have to equal 1. Because we can't find a probability of a single event, that has to be a range, the probability of A is less than or equal to X, which is less than X, would it be? It's the same as A is less than X, which is less than B, right? The symbols don't really matter, right? Because we can't find the event of one thing occurring. All right, and then we want to talk about identifying uniform probability distributions. Okay. So a probabilities distribution, right? If you have this, so I've used the example from our formula sheet. So here's the Nessa one. So this is what we're talking about. Okay. So if we want something less than a certain value, R, right? It's the integral from A to R of the function. And if we want it between a range, it's going to be between the two values, the integral of the value between them. Okay. And that's basically what this is saying, right? So if I want it less than R, there's my R value. I'm going to find it from the starting point and R value. So R minus the A value. And then if I want to find a range, I've got B and A. Okay, so here's an example. Continuous probability distribution is defined as f of x equals kx cubed in the domain from 0 to 6. So if we drew a quick sketch, 0 to 6, we have some value of x cubed. We're not quite sure. We want to find what x is, but area under here has to equal to 1. Okay, so if we were to integrate from 0 to 6, k of x cubed dx, the solution has to be equal to 1. So if I integrate that, I'll get k on 4, x to the power 4, from the range of 6 and 0, and that would have to equal to 1. Let's work this out. So 6 to the power of 4, right, over 4 is 324k. Now minus, if I plugged in 0, it just ends up being 0. So this has to equal 1. So k is really 1 over 324. So what that means is really the function, then f of x is actually 1 over 324 x cubed. Okay. All right, so let's look at the next one. I want to find the probability that my value is going to be less than 3. So that means I really want to find the integral. Now, because that's a constant, I just put that out on the outside of x cubed dx between the values of my function starts at 0 and 3, so I want all this part here. So from 0 to 3. Now, obviously, if it started at 1 or 2, then this value here would be that 1 or 2. Okay. So if we were to integrate that, we would get 1 over 324 x4 over 4. And we want it from 3 to 0. So plugging 3 for x, I get 3 to the power of 4, which is 81 over 4, minus 0. So that's that. And I'm multiplying that by its constant out here. Okay. So 81 over 4 multiplied by 1 over 324 gives me 1 over 16. So this solution is 1 over 16. Okay. So now I want the value. So what I really want is the integral from 4 to 1 of the same function. Okay. Now that we know that this is x to the power 4 4 to 1, we can plug it in. So we get 4 to the power of 4 over 4 minus 1 to the power of 4, which is 1, so minus a quarter. Plugging that into our calculator, 4 to the power of 4 over 4 minus a quarter. We multiply that by 1 over 324. We get 85 over 432. Okay. All right. If we have a continuous function and it's uniform, it means that the probability of each item occurring is always equal. So you get this kind of flat line. And so remember, the area under here is going to be 1. So the function is 1 over b minus a for a to b and 0 elsewhere. Okay. And the good thing is, if we take equal intervals, well, that probabilities of each equal interval will be the same. So here's an example. I've got this function. It's from 1 to 4, and the uniform distribution is a third. Okay, so we want to find the probability of x less than 3. So I get this part here, right? And really it's this blue part here. So the area of any rectangle is the base. So now here I've got 3 minus 1, so my length is 2 units. And then multiplying by its height, which is a third. All right, so in this situation, the area, or the probability, would be 2/3. Okay, if I want it between 2 and 3, let's say that was 2 and I'll say that was 3. Alright. Well, the area is length times width. So here we've got a length of 1, so width of 1, and a height of a third. So the probability would be a third. Okay, now if we did 3/4, right, or greater than 3, right, that's this part here, and that should be the same distance, the same length as this, so I should really get a third. Let's figure it out. So 4 minus 3 is still 1, the height's still a third, and I get a third as I expected. Okay, so equal intervals along the x-axis will have the same probability if the distribution is uniform. Okay, so good luck. Thank you.